University of Auckland in New Zealand. So I'll give you a quick overview of what my presentation is going to be. And because you all are engineering students, some of these things I will go over quite quickly. And in the meantime, if you have any questions, feel free to ask me in between. Don't feel like you're interrupting my presentation. I prefer for you to ask as we go. And of course, at the end of it, I'm happy to answer any questions as well. Okay? So I will talk a little bit about capacitors, which I'm sure you know all about. And then I will introduce supercapacitors and sort of highlight the differences between the two and some of the similarities. And I will also do a quick comparison between supercapacitors and batteries and why each technology has its own advantages and so on. And I will also talk about some of the creative ways that we have used supercapacitors for different applications, apart from some of the conventional applications of supercapacitors. And of course, I will talk a little bit about postgraduate study in New Zealand. And also, this is quite closely related to postgraduate studies in Australia because we have a very similar system, but we have some differences as well, which I will talk about as well. Okay? So, just to quickly introduce myself, so I actually completed my school education here in Sri Lanka, just like all of you. And at that time when I finished my school education, my parents had decided to migrate to New Zealand. So I was supposed to go to the University of Moroto, but I decided, okay, I will go with my parents. So I studied electrical and electronics engineering at the University of Auckland. So I graduated in 2006. So I actually returned to Sri Lanka to work at Motorola, which used to be called Symbol Technologies back then, as an engineer. So that was my first role. And then I moved on through several different roles as a business analyst at the London Stock Exchange Group, which I really didn't enjoy. And then I moved to the University of Moroto as a research engineer. And finally, I started teaching at the University of Sri Jayawardhanapura in the physics department. So that's what actually made me more interested in academia, and I decided to go and do my Ph.D., which I completed in 2017. And since then, I've been working at the University of Auckland in the same department as a lecturer. So some of my research interests are in supercapacitor applications. And during my PhD, I worked a lot on wireless power transfer and also electropermanent magnet-based applications because my PhD was basically combining both of those. And also another area that I'm quite interested in is STEAM education, or science, technology, engineering, arts and mathematics education for young children. So I also work as an advocate for women in engineering. So I'm currently the secretary of the IEEE Women in Engineering New Zealand North section. And I also support our Sri Lankan engineers as part of the IESL New Zealand chapter, where I work also as a secretary. And of course, I also wear many other hats in life, which we quite often forget. Without any other sidetracks, let's go into capacitors, right? So this is a technology that we all know from our A-level days. We've been learning about capacitors, and we talk about them, we talk about how they're used for energy storage and so on. So simply speaking, a capacitor has two plates where the area of the capacitor plates and the separation distance and the electrolyte that is between the plates determines the capacitance of a capacitor, right? So when we charge a capacitor, we simply need a voltage source or something that provides a current to charge a capacitor. And usually the voltage that the capacitor charges to is determined by this voltage source. So it's basically determined by this voltage source, because at the end of the charge cycle, no current actually flows through the capacitor anymore once the capacitor is fully charged. So I believe you all know all of that, right? So I'm not going to go into too much detail there. So the key point here is the time constant that's associated with the capacitor is basically determined by this RC circuit, right? So the resistance and the capacitance that is associated with this particular circuit determines how fast your capacitor will fully charge to whatever the voltage that is available, right? So when we charge or discharge a capacitor, it's not quite a linear function. So it takes 5 times that time constant that we calculate based on the resistance and the capacitance to actually fully charge the capacitor. And if we're discharging, it takes the same amount of time to discharge, right? So if the capacitance is large or if the resistance is large, that basically determines how fast or how slowly the capacitor charges, right? So the special feature here really is that we don't actually need any specialized charging circuits to charge a capacitor, right? So as long as we provide a voltage source, a capacitor can be charged. As long as we provide a discharge path, the capacitor will discharge depending on what's happening elsewhere, right? So this is basically something that we have used in some of our supercapacitor applications, where we make use of this simplified charging-discharging mechanism. So let me first introduce you to what supercapacitors are. Basically, how are they actually different? So supercapacitors are essentially larger capacitors. So when we talk about capacitors, maybe the biggest capacitor that you'll get with the conventional or the electrolytic capacitors is about 1,000 microfarads, right? So supercapacitors, we talk about farad, in the farad range. So maybe from 1 farad up to about 5,000-6,000 farads you can get with a supercapacitor. So the larger the capacitance, of course, the larger they get in size as well. So they then come to a range where they become almost comparable with batteries in terms of energy storage, but not quite the same, but they can store a substantial amount of energy inside a supercapacitor depending on the capacitance that you choose. So the difference with supercapacitors is that their construction is such that the surface area has been actually increased in such a way that the porous material provides more surface area so that it increases that A in the capacitor that we conventionally know, right? So, okay, it's supposed to have a nice little animation. Anyway, what actually happens inside the supercapacitor is that the activated carbon electrodes basically attract the ions in either direction to keep them charged. So that's technically how you charge a supercapacitor. So I don't want to go into the construction and the mechanics of how a supercapacitor works. But what we need to take away from here is that the energy that's stored inside a supercapacitor is determined by half C, the capacitance, times the voltage that you charge the capacitor to squared, right? So same as any other capacitor, nothing different, right? So the only difference here, why is the energy higher? Because C actually is much, much larger. So 1,000 microfarads versus 1,000 farads, you get a much larger energy storage capability with the supercapacitors, right? So there are several types of supercapacitors, and we also get what is called the hybrid capacitors, right? So they are basically in between supercapacitors and batteries. So the main difference here is in how the electrical energy is stored inside these capacitors. So the hybrid capacitors actually have a one electrode which is quite similar to a lithium-ion battery. And I'm not going to go into the details of that because I'm more interested in talking about some of the applications and something that we're trying to do in the near future. So some of the really interesting characteristics of supercapacitors, one is that they can actually, they're almost 1 million times bigger in the capacitance in comparison to some of the capacitors that you conventionally use, right? And also with capacitors, in comparison to batteries, you can charge and discharge capacitors virtually an unlimited number of times, right? With a battery, quite often you have a certain number of charge cycles that you can subject a battery to, right? Whereas with a capacitor or a supercapacitor, this is virtually unlimited, right? And the charging mechanism is quite fast and straightforward. And another interesting characteristic of supercapacitors is that they have a very low internal resistance, or in other words, what we call the ESR, equivalent series resistance of a supercapacitor, is quite small, right? And they have a high power density. So with capacitors, in comparison to batteries, while batteries have a higher energy density, capacitors have much higher power density. What does that actually mean? You can actually supply a larger amount of instantaneous power using a capacitor than a battery, right? So you can actually draw a much larger current out of a supercapacitor or even a capacitor in comparison to a battery, right? So supercapacitors usually are not constructed with toxic chemicals, and they have a relatively lower energy density in comparison to batteries. They can't be all that good, because if it was all good, then why are we even using batteries would be the question. So one of the drawbacks is that they have a lower energy density, and the other drawback, another reason why they're not as popular as they should be, is their lower voltage rating. Right? So if you look at an electrolytic capacitor, if you read the numbers on it, you will see usually they can take about 300 volts, 1000 volts across them, whereas with a supercapacitor, like a single supercapacitor, usually can only take about 2.7 volts across it. So this is one of the difficulties that we have to overcome when we're designing with supercapacitors, right? So like I said, they can't be all that good. There are some things that are not favorable, but there are ways around it, right? So when we charge a supercapacitor, we don't actually have to do anything special, right? We essentially have to charge it the same way that you charge a capacitor, right? So as long as you've got a simple RC circuit, and quite often the R is could be the internal resistance of the... Yes, you've got a question. That's completely fine. Oh. 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 එකම දේ අපි සුපර් කැපැසිටර්ස් ගොඩක් එකට දාලා V එක වැඩි කරගත්තොත් C එක හැබැයි ඒක දාන විදිහ අනුව වෙනස් වෙනවා. කැපැසිටර් එකෙන් කියන්නේ C normal capacity එක යඩුනාට එයාගේ රීවේට් කරගන්න ඕනේ V square. ඔව් ඒක හරි. සුපර් කැපැසිටර් එකේ එනර්ජි පැත්තේ වෙන වාසිය මොකක්ද? මිනිම ඒක ඇත්තටම ගොඩක් C කියන එක මිලියන් ටයිම්ස් විතර වැඩි කරන්න පුළුවන් සුපර් කැපැසිටර් එක. 1000 ටයිම් V වැඩි කිරීම නැති වෙනවනේ. ඔව්. ඒක හරි. අපිට එකම දේ 1000 ටයිම්ස් V වැඩි කරන්න එකේ V එච්චරම වැඩි කරන්න අපිට ගොඩක් ඇප්ලිකේෂන්ස් වලට අවශ්‍ය නැහැනේ. දැන් අපි 5 volts වගේ අපිට ඇප්ලිකේෂන් එකක් තියෙනවා කියලා හිතන්න. එතකොට අපි දැන් පොඩි අපිට ෆෝන් එකක් හරි නිකන් USB power ගන්න වගේ ඇප්ලිකේෂන් එකකට අපි අරක 1000 දුන්නාට අපි ඇත්තටම 1000 වලට ගොඩක් කලාවට ඔක charge කරන්නේ නැහැ. ඒක අර එයාගේ capability එක charge කරන්න පුළුවන්. හැබැයි මම කියන දේ තේරෙනව නේද? හැබැයි ඒක very good question, right? එතකොට අර ඇප්ලිකේෂන් එකේ හැටියට තමයි ඒක ඇත්තටම depend වෙන්නේ. Right? Yeah, so as I was saying, so to charge a supercapacitor, again, we don't need any special circuitry. Whereas if we compare that with a battery, right, with a supercapacitor with a battery, this is the main difference that we will see, right? Supercapacitor doesn't need special charging circuitry, while a battery will need a charging IC, voltage regulation, and all these other things. I will talk about it soon. So, this is what is called the radon plot, right? So this is something that compares the energy density and the power density of different materials, right? So different energy storage devices. So if we look at things like fuel cells or lithium-ion batteries, you can see that the energy density is much higher, right? Whereas with capacitors, so electrolytic capacitors, some of the larger conventional capacitors we get much higher power density, right? But supercapacitors sit somewhere in between, right? So they help you to combine the let's say the lithium-ion batteries or like lead-acid batteries or battery technologies and capacitor technologies. So it sits in between, which is one of the favorable properties that we actually use. So when we talk about power density, it's basically how much energy you can deliver in a unit per second per unit volume, right? And when we talk about energy density, sorry, this should be how much power and this should be how much energy it can deliver in, is how much energy that can be stored per unit volume, right? So I'm not going to go into all these numbers, don't worry. So it's more of a comparison chart that talks about the different technologies. So you can see I've got aluminium electrolytic capacitors, so the largest capacitors that you can get in the conventional capacitor range. And then here we have the lithium-ion batteries sitting on the other end of the spectrum. So supercapacitors, in terms of numbers, you can see that they sit in between. Whereas with the aluminium electrolytic capacitors, we can get around 630 volts or sometimes even more. And with the lithium-ion batteries, you can go to about 2.5 to 4.2 volts. Of course, depends on the battery and the application, but supercapacitors sit in between. So this is actually one of the biggest challenges we have when designing with supercapacitors, right? So in comparison with batteries, supercapacitors have quite a constant internal resistance, whereas the battery's internal resistance actually tends to change as you discharge the battery, right? So that's also another favorable property that we tend to make use of when working with supercapacitors, right? So when we discharge a supercapacitor, now this is again something that we have to deal with when we are working with supercapacitors. So a battery usually discharges slowly and it holds its voltage quite constant. And then all of a sudden the battery pretty much drops its voltage quite quickly, and round about this range, beyond that range, the battery you need to basically recharge the battery. So supercapacitor, right, can be basically discharges a lot faster, right? Supercapacitor discharges a lot faster, so that's why they're not suitable for all applications. That's why you need to actually work around them. So this is taking into account a single supercapacitor. It will discharge a lot faster, but so this curve is something that we need to work with and something that we need to work around. So again, one of the challenges that we have to deal with when working with supercapacitors, right? So I'll also show you some of the examples where we've made use of that in such a way that it becomes not so much of a challenge after all. So when we charge supercapacitors, I mentioned that we simply need a voltage source or a current source depending on how you want to charge it. Whereas when charging a battery, we definitely need one of those battery charger ICs based on the battery chemistry, or you need to design your specialized charging IC to make sure you're charging the battery under the regulated conditions that the battery requires. And quite often you will need some additional circuitry to keep the battery voltage regulated and so on when you supply it into the rest of the circuit, right? So in comparison, supercapacitors are much easier to charge and discharge. So this is something we make use of in some of the applications, right? So first of all, I'll talk about some of the very conventional applications. So if you look up supercapacitor applications on Google, you will quite often find some of these applications, right? So one of them is energy buffering. Similar to what we do with electrolytic capacitors, like in almost any power supply circuit that you deal with, you will have capacitors at the entry point of your voltage source. And these basically provide some energy buffering. So supercapacitors can be used for the same purpose in a more substantial manner. And also like fast charging applications, we tend to use supercapacitors. So again, quite mature technology exists using supercapacitors. And another application where supercapacitors are quite popular these days is regenerative braking in automotive applications, right? So these are some of the typical uses of supercapacitors. But some of the more creative uses where we've made use of these supercapacitor technologies. So this is not all work that I've done by myself. So this is collaborative work that has been done over the years in New Zealand. So one of the first applications that we've done is the supercapacitor-based lightning surge absorption circuit. So this was actually commercialized a few years ago by an Australian company called Thor Technologies. So technically, like I've kept all of the technical details off and tried to keep it as simple as possible just to keep it interesting. So technically what happens is when a lightning surge comes through, what we essentially have is a very high voltage which changes very quickly, right? So we've got a very high voltage available for a very short amount of time. So if we can harness that energy that comes through a lightning surge, perfect for application, perfect for like the Sri Lankan environment, right? So where we get a lot of lightning, right? So this energy is very quickly stored in a supercapacitor. You can't charge a battery with this because that a battery cannot charge as quickly as that. But a supercapacitor can, if done correctly, you can charge a supercapacitor in such a way that most of this lightning energy can be absorbed by the supercapacitor and even be harnessed in such a way that you can use it later on, like transfer it to a battery. But technically what has been done here is use it as a lightning surge absorber for a UPS system, right? So it's not a very big device. So that's one of the commercialized applications that was done right at the start of some of these research work that we were doing. And another creative application that they've done with supercapacitors is use it for water heating. Maybe not something very applicable to the Sri Lankan climate where the water is already quite warm, right? But in cold countries like New Zealand, when you open the tap, it takes a while for the conventional heating system to kick in and heat the water. So in the meantime, we end up wasting quite a lot of water. Like I think they did some calculations. It was quite maybe about a few liters of water just goes unused because nobody wants to touch that cold water. Right? So this is where we brought in a supercapacitor so that you keep the supercapacitor pre-charged and the supercapacitor can rapidly release this energy to rapidly discharge into the heating circuit and provide that large current it requires to charge quickly and then replenish this charge in the meantime. But that significantly reduced that water heating time so that water was not being wasted. And this was in the process of being commercialized by some of the heating technology companies around the world. So they just found it to be a little bit more expensive than they wanted to be. So something that didn't go forward into commercialization just yet. But with the maturity of supercapacitor technologies being cheaper, this can definitely be commercialized in future. So another application that we've done is using supercapacitors for renewable energy resources. So solar lighting, right? So we've got LED lighting and we've got the solar panels, but I mean, the difference here is we basically use the supercapacitors to be charged directly from the solar panels. So no inverters, no batteries, right? Simply charge the supercapacitors directly with a little bit of control, of course, so that we operate within that operating range of the supercapacitors, so that we charge the supercapacitors and then discharge them. Don't know why the animations are not working properly, but so technically this part of the circuit works independently, and in the next half cycle the supercapacitor basically simply operates by itself. So we charge the supercapacitors and discharge them into the lighting, so that we are actually not using any batteries or inverters, because solar energy is DC, so we can directly charge using that voltage source that comes out of the solar panels to charge the supercapacitors. But of course we need to make sure that there's enough control so that we cut off the supercapacitor charging at the right time and the discharging at the right time, so that we are operating within the limits of the application that we're using here, which in this case is LED lighting, right? So this was used for like self-contained cells, so that they operate off-grid. So that this was quite a successful technology, and this would be really appropriate for the current situation in Sri Lanka. The only drawback here is that supercapacitors tend to be expensive, but you can still find ways to do it with cheaper, you could maybe get 1 or 2 lights going when you've got power cuts. Even that's good enough in some cases, right? So something to think about, right? So another application where we've used supercapacitors to overcome the low efficiency of low dropout regulators. So are you all familiar with LDOs? Okay, so I'll just quickly take you through it. I don't want to give you a whole lecture on LDOs. LDOs are basically low dropout linear voltage regulators. So they take a voltage and give you a smaller voltage at the output, but the difference between the input and the output tends to be smaller, because the efficiency of these systems basically are dependent on the output voltage and the input voltage. Right? So the output voltage divided by the input voltage basically determines your efficiency. So if these are not close enough, you can see how the efficiency is going to drop. Right? So what we have essentially done here is we've included supercapacitors at the input stage, so that for half the cycle or part of the cycle, the supercapacitor is charging, so that it takes in that voltage difference. Right? It takes in a larger voltage and basically charges itself in such a way that it basically applies a much smaller voltage difference between the two sides of the LDO. And in the next half cycle, it basically cuts itself off from the input source and discharges into the output, so that this essentially increases the efficiency significantly in the end application. Right? So if you're only drawing power for, let's say, 50% of your operating cycle, you're essentially increasing your efficiency significantly, right? So this is essentially what we've made use of here with the supercapacitor assisted low dropout regulators, right? So the possibilities using supercapacitors are pretty much unlimited. You just need to get thinking creatively, put your creative hats on, and there are so many things that you can do. But of course, you need to work around those limitations I talked about. So something to think about, right? So I guess that brings the technical part of the presentation to an end. So I'm going to talk about postgraduate studies in New Zealand, and of course, again, related to Australia as well. So any questions before I go on? So if you have any questions, I'm more than happy to answer them later on as well. And of course, Singaling ප්‍රශ්නය වලට ප්‍රශ්නයක් නැහැ. මම කැමති භාෂාවකින් උත්තර දෙන්න පුළුවන්. So postgraduate studies in New Zealand. Let's start with where is New Zealand. So this is us in Sri Lanka. So here's New Zealand, halfway across the world, right? So if we are 11,000 kilometers away from Sri Lanka, right? So it's usually, if you're lucky, a 14-hour flight from here to New Zealand. I wasn't so lucky when I came, so we had to take a 28-hour flight this time. So usually includes at least one stopover. Some things to think about if you're thinking about higher studies, right? So New Zealand is also called Aotearoa in Maori, the native language of New Zealand. So Maori people are the indigenous people of New Zealand, and we have two islands, the North Island and the South Island. So the capital of New Zealand is Wellington, but Auckland, where I'm from, is actually the business capital and the most populated and the most multicultural city. So the major cities in New Zealand are Auckland, Wellington, Christchurch and Hamilton, which I've shown here on the map. So apart from Christchurch, the other three major cities are in the North Island. So the Northern Island is more populated than the South Island, but the South Island is of course the more beautiful one. So our population is 5 million people, which is a lot less compared to Sri Lanka, and the country area-wise is about 8 times as big as Sri Lanka, and we are known for having more sheep than people. So we get 3 sheep per person. So very interesting fact people find. So universities in New Zealand, we have 8 universities in New Zealand, right? So, and these are the only universities in New Zealand. I want to stress on that because when you talk to visa agents, they will tell you, oh, there's this university, there's that university. Before you talk to them, please refer to this list, right? So these are the only universities in New Zealand. So I've actually put them according to the rankings, the most current rankings. So the University of Auckland, of course, is the top university in New Zealand. And then we've got the University of Otago, actually, which is rated number 2 in New Zealand. But Otago does not offer engineering. So then we've got the University of, the Victoria University, which is in Wellington. So that is number 3. They also offer engineering. But in terms of engineering, I would say the University of Canterbury is probably the second best compared to like the other universities. Then we've got, so number 4 is University of Canterbury, number 5 is University of Waikato, and then we've got number 6, which is the Lincoln University, doesn't really offer engineering either. And then we've got Massey, which offers engineering. So Massey's got 2 branches, so their main campus is in a city called Palmerston North, but they've also got a branch in Auckland as well. And then we've got number 8, AUT. So quite often the University of Auckland and AUT are confused as the same, but it's not. So if you look at the rankings, it's quite different. So AUT also offers engineering. They also offer PhDs. So another option, of course, that you can think about. So just be aware when you think about higher studies in New Zealand. These are the only universities. Anything else does not hold university status. And if you're thinking about a PhD, definitely only these universities can offer it. But there are some other institutions that can offer master's degrees. But I strongly recommend, as you know, top students in Sri Lanka, you should try and focus on these ones and not those polytechnics and other technical colleges, right? So postgraduate degrees that are usually offered in New Zealand, so the top degree that you can go for, that you can work for, is a Doctor of Philosophy, or what we call a PhD. So this is the highest degree that you can achieve, and it is purely research based in New Zealand. So unless you're asked to take certain subjects, which usually isn't very common, a postgraduate degree is all research, a PhD degree is all research based, and can take anywhere from 3 to 3.5 years upwards to complete. So if you're thinking about timelines, that's what you're looking at. And then we've got the master's degrees. So I'm specifically talking about engineering in this case because all of you are engineering students as far as I understand. So engineering masters that are offered, basically I can speak for the University of Auckland because that's the one that I know the best, but each university has its own differences. But we offer two types of engineering master's degrees. So one is called a Master of Engineering Studies. So Master of Engineering Studies is a taught program, so you actually sit down and take courses, different subjects, and you also have some short research projects that you have to complete. And we also offer what is called a Master of Engineering, which is basically a purely research-oriented degree. So if you are thinking about going in for a PhD after a master's, you need to be looking into a Master of Engineering rather than a Master of Engineering Studies, right? So then we also get the degrees like a postgraduate diploma, which probably isn't really for the engineering students. It's for usually people who do a 3-year degree, whereas for you it's a 4-year degree. So your degree is considered an honours degree by the New Zealand standards. So when they do a science degree, usually the good students are offered what is called an honours year. So the top students are offered an honours year, whereas you automatically have got your honours year out of your 4-year degree, right? So just some of the things that we offer. And in terms of a master's degree at the University of Auckland, it's 100. You can choose between 120 point, 180 point, or a 240 point program. So these are all dependent on the faculties. So with the Master of Engineering, it's usually 120 point because it's a 1-year long degree. It's not a 2-year master's, but some other faculties offer 2-year masters. So if you're thinking about a different subject area, that's probably, it's different for the different subjects, but for engineering, it's usually the 120 point 1-year masters that you need to commit to, right? So usually to get into a master's program, you can get in with a bachelor's degree, like what you're going to have at the end of your studies, or a bachelor's, like an honours bachelor's degree, or a postgraduate diploma. Like, I don't think you need to worry about that. So if you're aiming, like I said, to get into a PhD program later on, then you need to basically aim for a master's, a research master's, or what we call a Master of Engineering degree. So there's also, I'll talk about it when I get to PhDs. So if you have a 4-year bachelor's degree, your final year is basically considered as postgraduate level study or honors level study. So you will be treated as an honors graduate. And if you are applying for a Master of Engineering Studies, the GPA, or what is called the equivalent GPA or GPE that you require is 4 out of 9 or higher. So I will share some links in the subsequent slides which will take you to the GPE calculator. So when you enter your GPA based on your institution and so on, it will do a calculation and tell you what your GPA calculates to as far as the University of Auckland's entry criteria is concerned, and then you can determine where you basically stand, right? So with a doctoral degree, like I said, it's a purely research-oriented degree, and you basically choose a topic that you're interested in. So you usually collaborate with a supervisor and generally talk to them. That's, at least for Auckland, that's how the procedure usually works. You identify some supervisors that you would like to work with based on their interest areas and yours. Because at the end of the day, you must think about when you pick a topic for your PhD, it's going to be something that you're going to have to work on for a few years. So if you don't like the topic, don't go for it, right? Or you're going to not enjoy, because it needs to be an enjoyable experience. So this was very good advice given to us when we started our PhDs. Choose a topic that you like, So quite often, many supervisors are happy to hear your ideas and work on a topic together with you that you can follow through for your PhD. And in some cases, supervisors have specific projects that they want to get done at the PhD level. In that case, they will say, okay, here's a PhD topic that I want a student for, and if you're interested, you apply for that. So if you look at the University of Auckland, like I'll share some resources, there will be a list of existing PhD opportunities, but your PhD opportunities are usually not limited to that. So if you think, I would like to work on this topic, do a little bit of research on that, is it actually a valid idea? And if it seems like a feasible idea, approach people who are working in that area, talk to them, and if you hear back from them, then that means they may have an interest in what you're interested in doing, and then you basically go forward to talk to them and build that relationship, and then they will guide you through the application process, right? And sometimes you may realize, actually, I thought this person is interested in my topic, maybe it's a person I don't want to work with, so then you basically move on to someone else. And also, if you write to someone, if you don't hear from them, don't be disheartened. They get a lot of applications or a lot of emails from students from across the world. So quite often, if someone responds, that means they're interested in your idea, they're interested in you. And it may just be that if you don't hear back from them, it's probably because the research areas don't quite align. So just keep trying, right? That's the best advice I can give you, right? So to get into a PhD, right, when you do the GPE calculation, it needs to be at least 5.5 out of 9 or higher if you're from an overseas institution, which will be you. So my husband studied at the University of Morotua. So one thing with Auckland and most universities in New Zealand, they take people in straight from undergraduate into PhD, okay? So you don't necessarily have to have a master's. So he didn't do a master's, but because he had a first class honors in his bachelor's degree, that was good enough for him to get into a PhD straight away. So if that is you, that is another opportunity. You don't have to worry about the master's. You can go straight through to PhD at the University of Auckland, and most New Zealand universities also support that, okay? So something for you to think about. So usually you need to have a first class honors or a second upper. Is that correct? Yeah, or a second upper, right? So of course depends on the institution. Some institutions have a higher entry criteria, some have a slightly lower entry criteria, and some supervisors, depending on the institution, like for example, my father works at the University of Waikato, so they have a way that where they can basically say, I can guarantee that this student will complete their degree. So even if the entry criteria isn't quite met, sometimes they can waive off that. Whereas unfortunately with the University of Auckland where I work, we have absolutely no control over that. So you must meet this entry criteria to get into a PhD program at all. Okay? Any questions so far? Right, so I think, so another thing I want to highlight, at the University of Auckland, we offer several postgraduate scholarships. So if you have completed your most recent qualification at the University of Auckland, and if you have gained 8 out of 9, a GPA of 8 out of 9, which is an A average as we call it, you will automatically qualify for what we call the University of Auckland doctoral scholarship, right? So this is for someone who has studied at the University of Auckland. So what some students do is they come in as a master's student, complete their master's degree. If they get that GPA of 8 out of 9, then they automatically qualify for that scholarship, no questions asked, right? As long as you've done your last qualification at the University of Auckland. Whereas for international students applying for the same scholarship, the entry criteria, scholarship criteria is dependent on the applicants, and usually you need to be in that first class honors range to be considered for that, for the University of Auckland doctoral scholarship. So this is usually 28,800 as the current rate, so 28,800 New Zealand dollars per year, and they give it for 3 years, but you can extend it for up to 3.5 years. So if you get this scholarship, then you're usually okay, and this is tax free, so you don't have to pay tax on this, and this is all for you. You don't actually have to do any teaching work or anything like that as they do in the US to actually get this, to get this money. So this is equivalent to what they call a fellowship in the US, right? So basically, if you meet that criteria, if you get this scholarship, it's basically money that you can spend on yourself. On top of this, they also pay your doctoral degree fees for 3 years, and can be extended up to 3.5 years, right? So we also have what is called a master's, University of Auckland Research Master Scholarship, but unfortunately that is only available for local students, and that includes this tax-free stipend as well as the compulsory fees that you need to pay, right? So, like I said, the scholarship is guaranteed for domestic students with an A average or higher, qualifying from New Zealand University, and high achieving students from international institutions will also be considered, but there is no guarantee for the international students for this scholarship. But of course, when you apply for your PhD at the University of Auckland, you will automatically be considered for the scholarship. So you will be told at the time of being admitted, or at the time of being told whether you were successful in your application or not, they will say whether you got the scholarship or not. So you already know whether you have qualified for the funding or not before you commit to your studies at the University of Auckland. Right? So I've included a link here which takes you through some more information you can read through to find out a little bit more about the scholarships, right? But of course, with scholarships, there are other pathways as well. So that is what is offered by the University of Auckland, but quite often supervisors have their own funding, right? Depends on the supervisor and depends on how big their research group is. And if they've got a grant for a certain research, they will quite often have a limited number of scholarships available. It may be 1 or 2 at the time, so then they look for the best fit for the project that they want to do. And you can apply for those scholarships, and quite often they will give you some information on what the scholarship includes, and the amount usually varies depending on how much money they have available. So it can be the same amount as the University of Auckland doctoral scholarship, which is about nearly $29,000 a year, or can be a little bit less depending on how much grant money is available, right? And there's also a number of government scholarships from the New Zealand government, as well as I believe things like Commonwealth Scholarship and things like that are locally available to Sri Lankan students. But I don't know too much about the ones that are available through the Sri Lankan system. But there are some government scholarships available through New Zealand. So something that you can also look into if you're not successful in being in getting the University of Auckland doctoral scholarship, right? So for each university, the scholarship criteria is also slightly different. So your PhD is basically also very largely dependent or very largely influenced by your supervisor. So one thing, like I mentioned before as well, make sure that you can work with the supervisor that you've chosen to work with, right? It's very important because it's a very long-term relationship, right? So at least 3 to 4 years you have to work with this person. And if you feel like, I don't like this person right at the start, it's going to be very difficult for you. So we have sometimes seen this happen to some students. It's nothing wrong with the student, nothing wrong with the supervisor. Quite often it's just that they're just not compatible with each other, right? So just make sure that you choose a supervisor that you can work with and choose a topic that you like to work on. That is really, really important for you to successfully complete your PhD on time and also be successfully employed in an area that you actually enjoy working in, right? So I would actually say that the supervisor is more important in most cases than the ranking of the university, right? But of course, make sure that you're still associated with a good university, because what you don't want to do is be associated with a university or like a smaller institution that, like, sometimes students find out once they arrive in the country that, oh, actually, although I was told that I'm going to a university, I'm not going to a university, I'm going to a small polytechnic institution, and they've already partially robbed you of your money that you've dedicated for your higher studies, which is really, really not what we want our students to experience, right? So it's always good to build that relationship. Make sure you check really well on the institution that you're committing to, whether it's in New Zealand, Australia, or anywhere else. Make sure that you get the credentials of that institution before you move forward. So some of the benefits in comparison to some other countries, like even Australia, that New Zealand has is a student who studies at a New Zealand institution. Let's say you're not successful in getting any of the scholarships. If you come for a PhD, you will be treated as a domestic student. So you will not be paying international fees like all of the other countries that you'd be applying to, like the UK or Australia. Even Australia doesn't offer this. So New Zealand treats all international PhD students as local students. So usually, and this is only for PhDs, not for masters. So for masters, you will still be treated as an international student paying international fees. But for PhDs, you will be treated as a domestic student as long as you are based in New Zealand. You're not trying to do your PhD while being overseas, right? So as long as you're in New Zealand, conducting your PhD from New Zealand, you will be qualified for that domestic fee, which is usually, I've included the numbers in US dollars, but it's usually somewhere between, for the University of Auckland, it's somewhere between about $7,500 to $8,000 a year for your compulsory fees, right? So let's say you're unable to secure a scholarship. This is another option that you can consider. So this is basically what you need to provide as the fee. And of course, there are other opportunities, especially in the engineering faculty. Especially in our department, we have a lot of undergraduate students. So because of that, we also have a lot of teaching assistant opportunities. So quite a lot of our students, PhD students, are employed as teaching assistants every semester. So even if you don't have a scholarship, quite a lot of them come even from Sri Lanka as self-funded students, and they basically earn the money that they need for their essential living expenses and so on, working as a part-time teaching assistant, which is also another thing that you can think about. So if you're successful in getting any of the scholarships, you can still work as a part-time teaching assistant, and you can earn on top of the scholarship money. So that's a really nice thing to be able to do. So the money that you get as a scholarship is basically a stipend that you don't have to do anything for other than your PhD work. But on top of that, you can work as a teaching assistant and be basically making extra money on an hourly basis. And quite often what we have found is students who come from Sri Lanka, they're quite committed. So they do a good job, and they usually, like, if you do a good job, then the supervisors, the lecturers will basically say, I want that person again, I want that person again. So usually our students have a good record. So another opportunity for you to think about, right? So once you complete your PhD or your master's, any postgraduate degree, usually within limits, of course, you are eligible for what is called a 12-month post-study visa, which is basically something that they give for you to seek employment. So basically you can look for a job once you've got your post-study work visa, and once you've found yourself a job in your area that you've completed your qualification, you can then basically apply for, is it a work visa, or they can apply for residence straight away, right? You can basically apply for the post-study work visa, and then you can go for the skilled migrant category. And quite often, most of the students who come to New Zealand for postgraduate studies usually find employment. I mean, I'm speaking for engineering, find employment, and they also successfully get their residence visas for New Zealand sorted. So it's another way of basically migrating into the country, if that's something you're thinking about in the long term, right? So as I don't know how applicable this is to all of you, but we also get PhD or master students who come in with families, like I did. So if you've got dependent children, they are classified as local students, so they will not have to pay fees for schools. Public schools will be free for them, and public and secondary education, so apart from tertiary education, public school education is basically free for children. So if you know someone who's looking to study while they've got children, it's also something to think about. And also, you as a PhD student, you get unlimited work hours, so it's not usually limited to 20 hours as they do with some of the undergraduate programs. So you get unlimited hours that you can work as a PhD student. So you can, outside of your PhD time, you can work part-time jobs, or even sometimes we get students who find like a full-time job, and then they work out a way so that they can do their PhDs and do their full-time jobs. But that's usually towards the end of one's PhD that they find this type of employee, right? So some of the research opportunities that are available at the University of Auckland at the moment, you can find them at this website. So it's basically University of Auckland link that I've included here. So that lists some of the opportunities that are available at the moment, but quite often it's not just limited to that. So like I said, find a supervisor who works in your area of interest, and then you start communicating with them if none of these particular opportunities interest you. So this system is actually being, like, it's being changed at the moment. So this is still available for you to have a look at, but in a month or two's time, we're going to basically move to what is called the discovery profiles, which is the link that I have included here. So if you basically can't visit this link, that means they've probably taken that system down, and you can basically find PhD opportunities in the profile, in the discovery profiles that will be available a little bit later on, right? So basically in my case, these are some of the areas, as I mentioned before as well, these are some of the areas that I'm interested in. And I've actually become particularly interested in these supercapacitor driven applications, especially in the renewable energy domain, right? So I currently have an opportunity here, which I will talk about soon. So this opportunity comes with funding, right? So apart from these supercapacitor driven applications, I understand not everyone is interested in the same topics, but I work generally in the power electronics area and general electronic design. And some of the other areas that I work on is electropermanent magnet-based applications, so that and wireless power transfer, and like of course STEAM education, as I mentioned before. But I think if you're seeking a PhD, you might be interested in these 4 areas. This is more for the the master's or the undergraduate degree level thing. So some of my collaborators, I don't know if you've had the opportunity to meet my father, who's actually a graduate from the University of Peradeniya, same faculty, right? So he's an associate professor at the University of Waikato in Hamilton, New Zealand. And then this is my husband. He's also one of my collaborators, so he works at the University of Auckland. There's of course, then we have PhD students, master's students that work with us, and if you'd like to join our team, drop us an email, drop me an email. So this is the particular opportunity that I was talking about. I'm actually looking for a student for this particular project. So what we're trying to do here is basically design smart devices. So not design smart devices from scratch, but design smart devices that actually can be charged using solar energy. So basically harvesting solar energy and basically putting supercapacitors in between so that we can quickly charge these devices. So there's a lot of work involved here. So I like to title itself Charging Portable Smart Devices. So the application I would ideally like to start with is a smartphone. So this opportunity, so I've actually been awarded a grant to do this by Meta Research or Facebook. So with this opportunity, I am able to provide a stipend of $15,000 per annum. So it's not as high as the $28,800 that the University of Auckland doctoral scholarship is, but I am able to provide $15,000 per annum for 3 years plus your essential fees. But there's only one opportunity here. So of course it will have to go to the most suitable candidate. And I've included a link here which actually lists more information on this and how to apply for it. So if you want to know a little bit more about this particular opportunity, do send me an email, or if you want to think about any other opportunities as well. So in this case, the PhD will be awarded by the Department of Electrical Computer and Software Engineering at the University of Auckland. So that's where your degree is going to come out of. And usually, like I said, it's about a 3-year commitment. Of course, depends on how fast you want to go. We've sometimes had students submit after about 2.5 years. But so this is basically an opportunity that is available with me at the moment. Okay? So some other reasons to study in New Zealand. There's a little bit of tourism propaganda in New Zealand. So it's one of the most beautiful places. So if you're into any of these things like nature, adventure sports, these are some of the reasons why students really enjoy New Zealand. So something for you to think about. I think that brings me to the end of it. And if you have any questions, I'm happy to answer them in either language. Okay? Yeah.
Can you explain a bit about your research regarding the wireless power transfer?
Yeah. So, actually, if you look up the University of Auckland, our department is actually quite strong in that research area. So what we basically do with wireless power transfer is we work on different applications. So we've got a strong group that's actually working on electric vehicle charging. So because as electric vehicles become quite popular, at the moment it's all plug-in charging, but what they're trying to do is a bit of, so they've already got systems in place for static charging, but they're also trying to do a little bit of dynamic charging as the vehicle moves. So what we use is a technology called inductive power transfer. So technically you excite, basically the transformer technology, right? Essentially a loosely coupled transformer, and then we have the primary side being excited, and the secondary side basically induces a current accordingly, and that is being basically then that power is being utilized to basically in different applications. So unlike a 50 Hertz transformer, which is usually what we have in all of our systems, we usually work in the 80 to 100 kilohertz range. So like, I mean, they call it high frequency. I mean, relative to 50 Hertz, yes, it is high frequency. So depending on, of course, the application, but there are other applications, like smaller applications. I actually prefer to work with the smaller applications. So like for my PhD, what I was working on was something called a microfluidic actuator. So it was basically an actuator system that was for a microfluidic valve for delivering small quantities of liquids. So basically what I was working on was delivering power to actuate that valve wirelessly without having to make contact physically with the primary side. So that's a really strong area of research at the University of Auckland, if that's something that you're interested in. Okay. Any other questions?
Madam, in New Zealand we have heard some electronic vehicles. In Australia, you talked about supercapacitors that we can use to charge some things. Do New Zealand people or Australian people, basically New Zealand people, do they use supercapacitor to charge for charging purpose in the electronic vehicles?
In electric vehicles?
Electric vehicles. Like Tesla.
So there's some work being done there, but New Zealand doesn't, basically we don't manufacture our own cars. To be honest, New Zealand has a relatively smaller electronics industry, right, compared to like places like the US. But there was some really interesting work done by Ferrari. So Ferrari built a totally supercapacitor based car, electric car. So they basically got rid of batteries, right? But with most of the conventional cars, they use them in the fast chargers, but not quite just complete. None of the electric cars at the moment are completely batteryless. So they still use the batteries, but with the fast charging that's coming into the newer electric vehicles, like for example, I believe Mitsubishi has fast charging, and any other manufacturers? I know Mitsubishi does, but BMW, yeah. So BMW also has some mature EV technology. So they're the ones who have been doing EVs for a relatively longer time. So they've got supercapacitors in more of a buffering type of application. So with the fast chargers, so some of the conventional applications I mentioned right at the start, that's where they use supercapacitors at the moment with EVs. Right?
Madam, if they use the supercapacitors, isn't it a possible way to reduce the space that battery needs?
To reduce the?
To reduce the space that battery needs in car? By using
it needs to be very carefully designed. So if you basically go for a small, like, if you're going for like a larger supercapacitor, it will be almost as big as a battery. But supercapacitor technology is constantly evolving. So what we see today, we will see a much smaller version of it, or we're expecting to see a much smaller version of it in 5 to 10 years. So that's when, we can basically think about, can we reduce the space? Can we essentially reduce the weight of the battery? Because that's one of the main things that you need to consider when we are dealing with EVs, right? So yeah, it's definitely possible, but with the current technologies, with careful design, it may be possible, but of course, I can't say if the battery is this big, the supercapacitor is that small, not essentially, not with the bigger, because for a car you need to essentially store a large amount of energy as well. Yeah.
And this is about a bit more technical question.
Yeah.
Do supercapacitors achieve that supercapacity capabilities with the increased size, or does it use some other technology?
So you mean with the supercapacitors like?
Yeah, they have more better properties than a normal capacitor because of the size of.
So basically because of the capacitance. The main thing is the increased capacitance, right?
That is through the size of the.
Yes. So essentially we can package like some of these really small supercapacitors. Of course, they are not as big as 1,000 farads, but we can get, for example, a 1 farad capacitor, which is essentially almost paper thin. So like those would be ideal, but of course they may be about 0.2 farads. But compare that with a 1,000 microfarad electrolytic capacitor, that's still small. Does that make sense? Yeah. So it's essentially in the construction or the internal construction of the supercapacitors, that's where the advantage is, without having to essentially, if we built conventional capacitors to be bigger, we can of course get the same capacity, right? Yeah. But it's basically the internal construction, that activated carbon electrodes with that porous material, that's what gives it that increased surface area to give you that higher capacitance. Did I answer your question? Yeah. You have a question?
Application in a lightning
Oh. 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 එතකොට ඇත්තටම series parallel combination එකක් තමයි එතන පාවිච්චි කරලා තියෙන්නේ.
series capacitors ගන්න වෙනවානේ voltage එක maintain කරලා.
මෙම ඇත්තටම modules තියෙනවා. දැන් හදපු modules ම තියෙනවා. එතකොට ඇත්තටම දැන් අපි එක capacitor එකක 2.7 volts කියලා කිව්වට දැන් 56 volts වලට වගේ හදපු modules උත් තියෙනවා.
ඒකේ size එක වැඩි.
එතකොට size එක වැඩි වෙනවා.
voltage එකට යනකොට ලොකු size
මෙහෙමයි ලොකු voltage එකක් එකම දේ ලොකු voltage එකක් ආවට පොඩි වෙලාවයිනේ apply වෙන්නේ. එතකොට super capacitor එක දැන් අපි super capacitor එකකට 100 volts දුන්නා කියමු. හැබැයි එයා එක පාට 100 volts වලට charge වෙන්නේ නැහැ. එතකොට එයාට පුළුවන් ප්‍රමාණයට charge වෙනවා. අර ඒක ටක් ගාලා cut වෙනවනේ. ඒ ටක් ගාලා cut off වෙන එක තමයි ඒකේ තියෙන advantage එක. එතකොට දැන් අපි හිතමු lightning surge එකක් ආවා කියලා 400 volts. super capacitor එකට 400 volts charge වෙන්න බෑ. එයා 400 charge වෙන්න ගියොත් එයා පිච්චෙනවා. හැබැයි එයාට අර time constant එක හින්දා එයා charge වෙන්නේ ඊට වඩා පොඩි ප්‍රමාණයක්. හැබැයි එයා අරකින් energy ටිකක් ඇද ගන්නවා lightning එකෙන්. මම ප්‍රශ්නෙට උත්තර දුන්නා. right. Yeah.
Clarification about the funding.
Mm-hmm.
Like, is that fellowship?
Yeah.
The value of the fellowship depends on the project. Oh, what is that? The 15,000 is it a research assistant or?
No, so it's not a research assistant position. So the 50. So basically, the funding you're talking about the particular project I have, right?
How does it differ from that? There's a fellowship.
Yes.
So does it depend on the project?
So this one is dependent because I have been awarded this fund specifically for this project. So I am looking for a student. So it has to be the same topic. So in terms of whether it's a fellowship or not, it is essentially a fellowship, but the amount of the fellowship is smaller. So we don't call it fellowship in New Zealand. So we call it a scholarship. And what we call is, like in the US, they call it an assistantship, I think. So that is basically you are given a certain amount of money, but you need to basically work as a teaching assistant for your PhD supervisor, usually in the US, right? So with the New Zealand scholarship system, you don't have to work for it. You just have to do your PhD. If you are awarded a scholarship, it's a scholarship. It's what we call a stipend. So basically, you don't have to do anything other than your PhD to get that, right? So with the university scholarship, the doctoral scholarship I was talking about, it's not dependent on the project. So that is you're considered for it more centrally. So the scholarship office will look at all the PhD applications that come through, and then they will basically look at it's basically GPA dependent, more or less. Right? So that's that's the difference. So with if you contact a supervisor, for example, what they do is they will, if they have a grant, then the supervisor, and of course within reason, you've got to justify with the scholarship office. This student has been the student has to be granted entry to Auckland. And if they've met the entry criteria, of course, it's got to be, out of the applicants who have applied for it, it's got to be the most deserving applicant who gets that scholarship, the individually available ones. So different supervisors have different systems. So I know some of them, they actually get the students to do a test. So they get them to sit a technical test, and you basically need to pass that to get in. Because sometimes as supervisors, for us, it's really difficult to basically say, okay, so this student comes from a university in a country that I am not familiar with, for example. So for me, personally, I know that if someone comes from Morotua or Peradeniya or any public university engineering faculty, I know that it's a good student. But the university doesn't know that, right? So usually Sri Lankan supervisors, people who are associated with Sri Lanka know the Sri Lankan system. So we know how hard it is to already get into the university. So I always say even the bottommost student from one of these universities is still a really good student, right? So that's one of the advantages I guess you have going for someone who understands your system. So for example, an Indian supervisor will know the Indian institutions better. So it's an advantage, but of course, like I said, you need to find the supervisor that you can work with. Right? Did I answer your question?
So it's a grant to a relevant project, and we don't need to worry about the scholarships awarded by the university.
Yes. So for example, actually for anyone who applies for this, because anyway they have to get the entry. They have to get entry into the University of Auckland, which is completely beyond a supervisor's control. And of course, if you get the University of Auckland doctoral scholarship, I always say go for it, because that's a higher amount, right? So that's you go for it, and this amount is available for someone who may not qualify for that scholarship, right? So and anyway, when you apply for entry, you're already automatically considered for the doctoral scholarship. Okay. Any other questions?
What's your advice for a student who's applying for PhD in New Zealand? GPA 3.5 or 3.6-ish?
3.5 out of 4.2, right?
4.0.
Or 4.0. He can probably answer that one. What does that convert to?
I know from 4.2.
Yeah, because Morotua does it on, it's a 4.2.
Basically, it's a second upper.
Usually second upper should get entry into PhDs straight away.
Let's say from 4, 3.5 out of 4. Is that like an 8 or what is an 8? 3.4.
Top 3.3
D class.
D class.
3.4 is like.
So they have guaranteed scholarship for anyone who's done a master's and
Yeah.
that's 8 out of 9. 8 is an A average.
Yeah. So usually A average will be considered but unfortunately for international students, there's no guarantee. That's the thing.
That's the thing.
Right?
It depends on the number of applicants at that time.
Yeah. Because sometimes people actually come for a master's for that reason. Because quite often we know that someone coming from here or Morotua is almost if it's a hard-working student, they can get that 8 out of 9 average.
Still can have at least an A minus average. You are moving the chance.
Yeah.
But not guaranteed.
Not guaranteed. But the good thing is you apply, application is as far as I understand, you don't have to pay anything to apply. So you apply and see, and then if they say you got it with the scholarship, then nothing like trying, right? So
Previously, you could apply for a number of times.
Yes.
And the time of entry. But nowadays it's it's just like
Yeah.
we have only one chance.
You have only one chance, but I guess it's got ups and downs. So quite often students come thinking, oh, if I'm not successful in the first round, I can try second time, third time, fourth time. Right? So there was no limit to how many times you can apply for it. But then sometimes you never get it. But here,
It's not just the GPA, because
yeah, that's also really important. This is what we realized.
We've seen like students from China, they get really high GPA, but they still don't receive the scholarship.
But also, like the recommendations.
They're looking for an overall research. So someone has done some other activities, some research could be that if they have done some research activities before coming to a PhD, then that would really support the application.
Yeah. If you can get some papers published in IEEE, for example, I mean, make sure it is published in a good, conference or good journal or something like that. That of course supports you. And also another thing that we personally found supports you is your recommendations, right? So usually students we like to go for someone who's taught us, someone who's worked with us, but you need to make sure you get not something that says usually it's supposed to be confidential, but not something that says I recommend this student for this scholarship. That's not going to get you the scholarship. But I mean sometimes that happens as well. So if you can find someone who you have a good relationship with, so that you can specifically say, I would like you to recommend me in this way. That kind of relationship. You can do that with maybe an employer or a teacher or maybe your final year supervisor or someone like that. So that seems to, this is our personal experience. I have no evidence to support this, but yeah, recommendation plays a big role.
Since you talk about the researchers, so if a student is applying for a completely new research opportunity, so what is, will they consider it?
It depends on the supervisor. It is highly dependent. For example, if it's a supervisor who's got a very strong research group and they have specific things that they're working on, they will almost disregard your application, right? But then you get supervisors that are open-minded, right? So, they like to try this. If a student, personally, I don't mind if a student comes to me with a project, feasible project, or seems feasible, because with research you never know, right? Otherwise it's not research. So, if the project seems feasible, it's well supported, and if the student is interested, usually, and if it aligns with my work. So if someone comes to me saying, I want to do a PhD in software engineering, I'm basically going to say no, right? But if it's something in my area, if it's in power electronics, for example, it's something I would definitely consider. It's something some supervisors, it is very dependent on the supervisor, and don't be disheartened if someone ignores you. So just keep trying. And of course, try different institutions, try different supervisors within the same institution. And also another good thing to do, if you've identified a particular supervisor, you've got some communication going, before you commit, try and talk to their students, right? Try and talk to their existing or past students, right? They can give you real information, right? What you see on a profile of someone, what you see on paper is not everything. Someone may be a strong researcher, but sometimes we've had one of our friends, he's basically had he started with my husband and he's still doing his PhD. It's almost 10 years now. And it's because he basically can't get along with his supervisor. So that's a very unfortunate situation to be in, but try and do some background research. I know it's not always possible, but try and do some background research if you can on the supervisor, because that makes a big difference.
Let's say a student is currently working in a research associated with computer vision.
Yeah.
And then if we is applying for PhD in power electronics.
Yeah.
So what will be the supervisor's impression about him?
Supervisors' open-mindedness, basically, right?
Usually contribution comes under the software, computer system.
Yeah. So, I mean, if you basically want to go for like, if you want to continue that path, computer vision or something like that, you want to find someone in the same area. But if you want to switch areas, you can always do that. There is, I mean, my husband is a classic example. Maybe he can share a little bit.
I started with one supervisor, but after a while, at that time, I didn't have a particular topic. So, but within the first 3 months, I realized like it's not going to happen because it's not really my area. So after a while, I found a different supervisor with research. I was thinking at one day. So then I switched supervisor, but you have to do that at an early stage of the PhD. Usually, when you're doing a PhD, you have kind of like a examination within 1 year. It's not really an examination. You have to work for 1 year and show that you can progress for the next couple of years, 2 or 3 years. And if you can't really show evidence that you can progress, then they will terminate the PhD after 1 year. Usually you do that within 1 year, 1 to 1.5 years time. So if you're changing a supervisor, it's better to do it before then. Like, at least at that point, because otherwise you have to redo everything. So even it's you don't really have to find a supervisor at the start, but it's better to find a good supervisor from the beginning. A supervisor can support throughout your PhD, but not just to progress in your research, every day.
It's a long-term relationship, like I said. It's like being married to someone for a few years, right? So, I mean, because they especially with our students, we think about their mental well-being, physical well-being, because sometimes it's not a 1 year project, a PhD usually. It's a long-term thing, and you've got to stay interested. So that's why I said choose a topic that you like, right? So I mean, if there's an opportunity in the area, if you're not particularly interested in one thing, then you are probably open-minded to something. But you still have, having done your degree for 4 years, you will know I'm interested in certain things. I'm not interested in certain things. So that should give you some idea where to start. Right? Or maybe you think, I want to try something new, and that's also possible. So he basically switched from telecoms to power electronics. He finished his PhD in telecom, but then now he's in power electronics. Yeah. So it's always possible. Any other questions? If there are no other questions, maybe we can wrap up.